right? This is functions lesson number 2, page number 9, example number 1. What he has given, f of x is equal to x plus 1 by x. They prove that f of x whole square is equal to f of x square plus f of 1. Now I am going to take, this is LHS part, f of x whole square. So now I am taking in place of f of x, I am taking the value of x plus 1 by x and whole square. A plus b whole square, this is a square, that is x square, plus b square 1 by x whole square, plus 2 into a into b. In place of a you have substituted x, and in place of b you have put 1 by x. Now what you are going to get, this is x square plus 1 square by x square means 1 by x square, plus 2 1 you are getting 2. This is LHS part. Now proceeding going with the RHS part, first we will evaluate f of x square, f of 1 separately. Now what is f of x is given, x plus 1 by x. Now I will be keeping this as result of 1. Now in place of x, since you have got x square, in place of x I am substituting x square, put x is equal to x square in result 1. Now f of x square is equal to, this is in place of x I have substituted x square, this is x square, in place of x I have substituted x square, this is 1 by x square. This is first part. The second part is, in place of x I am substituting 1. Now here put x is equal to 1 in 1, what I will be getting, f of 1 is equal to 1 plus 1 by 1. 1 by 1 is nothing but 1, 1 plus 1, therefore this is 2. I am adding both. What you are going to get, f of x square plus f of 1, x square plus 1 by x square, and this is plus 2. Now as I observe, at this part and this part, both LHS and RHS are same. Therefore I write, this is nothing but LHS is equal to RHS, and this is where you need to understand. I hope that you understood the problem. I'll go with next one. Now here we have one more problem which is very important. Frequently they used to ask in IP. Now what is the question is, page number, this is going to be 12 and this is example number 8, a most frequently asked question. What is given that f of x is equal to, he has given that cos square x plus this is nothing but sine to the power of 4x. Now I'll write this is 4x, and here this is nothing but sine square x and plus this is cos to the power of 4x for every x belongs to real numbers. Now what they are asking, then this is show that f of 2012 is equal to 1. Now what I am going to do is, I am going to do the solution part. Now here we have got, this is nothing but f of x, cos square theta can be written as 1 minus sine square theta, this is 1 minus sine square x, plus you are going to write sine to the power of 4x. Now sine square theta can be written as 1 minus cos square theta, and this can be written as cos to the power of 4x. Since I am writing this is nothing but cos square x plus this is sine square x is equal to 1. Now next step, what I am trying to do is, f of x is equal to, from the respective two terms I am taking sine square x out common. Minus sine square x if I take out common, in place of this I am getting 1, plus is leads to, again converted as minus, because minus you are taking out common. Now minus into minus you are getting plus. Among 4, 2 has gone outside, one more 2 is left, so I'll be writing sine square x. Now in the denominator 1 minus this is cos square x, I am taking out common. Now since minus cos square x has take out common, what you are going to get inside, you are getting 1, and plus will become minus. Among 4, 2 has gone outside, one more 2 is left, this is cos square x. Now next step I will be writing in this way, 1 minus sine square x, 1 minus sine square theta, if I transpose this to right hand side, 1 minus sine square x is equal to cos square x you are getting, that is 1 minus sine square theta is cos square theta. So 1 minus sine square x is cos square x. 1 minus, this is going to be cos square x into 1 minus cos square x is equal to, this is you are getting sin square x. As you observe, the numerator and denominator, this is 1 minus sign is same, sin square x is there, cos square x is there. So numerator is one term, denominator is one term, both the terms are same, you can cancel. So what you are going to get, f of x is equal to 1. So first you need to understand one point. What is that? This is going to be the constant function. Do we have any variable beside x? Nothing is there. So what you have to do is put x is equal to, this is nothing but 2012 in, let us say this is result 1. I am taking the result 1. Therefore, I am getting f of 2012. The result is nothing but 1. That means if I substitute 2012, if I substitute 2021, anything, the result is going to be 1 only. That we need to understand. I hope you understood this problem. Let us go with the next module. That is very, very important. Now here, guys, most of the times, you need to understand one part. If he is using something like word surjection, don't get confused. Surjection means whenever it gets, it depends upon, this is f of x. That simple logic you understand. What do you mean by surjection? Simply I'll explain in one word. This is going to be the function f is mapping from a to b. Therefore implies what exactly you are going to get. I'll be writing f image of x is equal to y. The reason is that suppose this is going to be the set A which contains x, and this is going to be the set B and which contains y. Now f is a function from A to B. So first you need to understand that we say that this y is called f image of x. What is this? This is going to be called as domain. What is this? This is going to be called as codomain. That means codomain is nothing but that indicates y is equal to f of x. Suppose whenever he is functioning f of x, he will talk about surjection. Surjection means for every element of B should paired with A, provided if it is a function from A to B. So first you remember this area. What we are going to do, whenever we get surjection problems, he'll give domain elements. The domain elements we are going to substitute in this formula, whatever he gives, then directly we keep on substituting by substituting the results, we'll getting the results. That's it. Substituting the values, we'll get the results. For example, now what he has given, in the mainly 3 problems we need to focus. And that 3 problems are going to be very important. For example, page number 13, and I think this is Roman number 1 and problem number 5, which is connected to A is equal to, he has given that -2 -1 0 1 2. As I know, this is going to be called as x values. Now simply remember this diagram wherein you can understand about the surjection part. This is set A, this is going to be set B, this is x, and this is going to be f of x, which will be called as a y, and this is f is a function. You are talking about surjection. So what exactly this gives? Domain. That means domain, the set of f images of A. That means f of x values will be considered as range. For example, now I am going to take what he has given. F of x is equal to, this is nothing but x square plus x plus this is nothing but 1. I'll keep this as result 1. Now what is asking? He is asking about what is codomain B. Now what are the elements which are there in set B we need to find. What I'll do is, I'll be taking all the x values which is connected to domains. Now here you are going to take export x is equal to -2 in 1. So what you are going to get, f of -2 is equal to, you are getting -2 whole square, this is -2 plus 1. Minus in the square will become plus 2, square is nothing but 4, plus into minus, minus 4 minus 2 you are getting plus 1, 4 plus 1, 5 minus 2 is nothing but you are getting 3. Now here you are going to write put x is equal to minus 1 in result 1. You are getting f of minus 1, this is minus 1 whole square, this is minus 1 plus 1, 1 minus 1 plus 1, both gets cancelled, the result is nothing but 1. Now coming back to the next point, put x is equal to, you are getting 0 in the result 1. If I put x is equal to 0 in 1, you are getting f of 0, this is 0 square plus 0 plus 1. So what is the result? You are getting this is again 1. Now coming back to this side, what I'll do is, now put x is equal to, this is nothing but 1 in result 1. So what you are going to get, f of this is 1 is equal to, this is 1 square plus 1 and this is plus 1. So f of 1 is equal to, you are getting this is 3. Now you are going to write put x is equal to 2 in result 1. So here f of 2 is equal to, this is 2 square plus 2 plus 1, and upon substituting this is 4 plus 2 plus 1, this is f of 2 is equal to what exactly you are getting, 4 plus 2 6, 6 plus 1 is equal to 7, right. Now what are the elements in set B? The set B elements are going to be, you have to say f of minus 2, then f of minus 1, f of 0, and this is f of 1 and this is f of 2. So instead of simply we write the first value is nothing but 3, the second value is nothing but 1, and the third value f of 0 is equal to, again this is 1, and f of minus 1 is also 1, f of 0 is also 1, and here you are getting f of 1 is equal to 3, f of 2 is equal to 7. But as I observe, in the set, the repeated elements you can't take into consideration. Simply you write b is equal to 1, 3, 7, and that is going to be the answer which you need to give. I think hopefully you understood this scenario. Whenever you have been asked with surjection, simply take f of x function and whatever the set A elements he has given, you simply keep on substituting f of x. That gives set B, because f of x contains in set B. I think hope that you understood this problem. I'll go with next one because there are 3 modules which you need to understand. So I'll be going with next one. Now, this is Roman number 1 of exercise 4A, in which you have this problem. What is that? The problem number something like this. Alright guys, now what I'm going to do is, this is problem number 6 in Roman number 1. Very simple. In set A, he has given the elements that is called domain elements. This is 1, 2, 3, 4. That is the values of x. Now he has given that f of x values. F of x is a function is given by x square minus x plus 1 by this is x plus 1. Now what is asking? Range. If he is asking range, if he is asking surjection, it's pertaining to the same. Now here what we need to do is, I'll be taking this as nothing but put x is equal to 1. I'll say in the result 1, I'll be taking this as 1. I'll be writing this as f of 1, 1 square minus 1 plus 1 by 1 plus 1. So 1 minus 1 plus 1 by you are getting 2. 1 gets cancelled, you are getting 1 by 2. That is element which is there in set B. Okay, now you are going to write this is put x is equal to 2 in result 1. I am going to get this is f of 2. 2 f of 2 is equal to 2 square minus 2 plus 1 by 2 plus 1. That is 4, and you are getting this is minus 2 plus 1 by 3. 4 minus 2 is 2. 2 plus 1 is nothing but you are getting 3. Now here 3 by 3 you are getting, the 3 by 3 result is nothing but 1. Okay, I'll be taking the second, third value. Put x is equal to, this is 3 in result 1. As I observe, what I'm going to get here, f of 3 is equal to, I am getting this is nothing but 3 square minus this is 3 plus 1 by you are getting 3 plus 1. So 9 minus 3 plus 1 by 4. 9 plus 1 10, 10 minus 3 that is 7 by 4. The last one was you are going to write put x is equal to this is nothing but 4 in result 1. You are getting this is f of 4. This is 4 square minus this is 4 plus 1. This is 4 plus 1. This is 16 minus 4 plus 1. This is 5. 16 plus 1 17. 17 minus 4. 17 minus 4 is nothing but you are getting this is nothing but 13 and the result is nothing but in the denominator 5. Now here what you are going to write and the set B elements you are going to write, the set B elements are something like this. 1 is going to be 1 by 2, simply write in serial order. This is 1 and this is going to be 7 by 4 and this is going to be 13 by 5 and this is final answer and you need to put on. Right. Now coming back to the main important problems of exercise 4A I have finished, and in my next session I'll be going with the respective part. Thank you.